everybody. Welcome to Friday's notes. This is 9.2.2. So, what we talked about today, we did the 8.3 Twiz, and then we went through and worked part of example 2. So, this video is actually going to cover everything. So, if you were in class today, some of this you'll be familiar with. Feel free to skip around. And then for folks that were not in class today, just kind of go the whole way through. All right, so the first thing I gave you is just an idea of how the College Board grades these significance test questions now, all these inference questions. So in 2019, which then rolled out for the exams in 2020, College Board rolled out a new grading system for these. They put out what they call a new CED. And they shifted how they grade these questions. So if you look at any rubrics from prior to 2020, like the problems and the calculations will be the same, but the way they graded them has shifted a little bit. So just be aware of that if you look at some old ones. So the first thing they look at, and for these 3 sections, what I mean is they're going to be doing E, P's, or I's for each of these 3 sections. So section 1, they're looking to make sure you state the hypotheses correctly, you identify your parameter, and you define it in context. And then that you identify your test by a name or you give the formula. I encourage you to write both in class because my hope is on the day, then you'll at least remember to do one of the 2. But they are only looking for one. So that's section 1, and so that's the state section and then part of the plan. Then section 2 is where all the math is. So it's checking your 3 conditions, actually finding your z-score, and then finding your p-value. So then for 3 is it's basically your entire conclude section of state, plan, do, and conclude. It gets its own grade. So the conclude is where you're comparing your p-value to your alpha. So you're saying it's bigger than or smaller than. You are making your corrected conclusion, meaning you are either rejecting or failing to reject. And then you're putting your conclusion in context. So those 2 sentences that we write for the conclude cover all 3 of those. What that means, means that it is possible to get a 3 out of 4 on this FRQ without actually having to do math. If you can do section 1, section 3, and then whatever the follow-up question is, you could get away with not knowing how to do the formulas. Now, I wouldn't recommend it, but that is an option. And where that comes in handy is if you just have a moment and you freak out on the FRQs, or if you are running out of time and you have to quick do something. If you can't work the whole way through, you could just pick a number for your p-value. So let's say I just decided that I'm going to use a p-value of 0.02, and I just write that down. I don't give any supporting evidence for it, I just pick it. So I wouldn't get credit for section 2. But if I correctly do a conclusion based on that p-value, I will still get credit for section 3. And then if I answer the follow-up question correctly based on that p-value I just randomly picked from thin air, I will also get full credit. So it is possible to at least get a 3 out of 4. So definitely don't leave these blank. If you don't know what you've got, pick a number and go with it and keep rolling. And then that 4th question, when we're doing the follow-up, that's usually the part B's that I've been referencing. They're usually going to ask you about, well, did you make a type 1 error or type 2 error, or what would happen if you changed the significance level, things like that. So in the second example today, we're going to look at the type 1 or type 2 error question, so you can kind of see what that looks like. All right, so then we're looking at example 1. We have a recent report stated that less than 35% of the adult residents in a certain city will be able to pass a physical fitness test. Consequently, the city's recreation department is trying to convince the city council to fund more physical fitness programs. The council is facing budget restraints and is skeptical of the report. The council will fund more physical fitness programs only if the recreation department can provide convincing evidence that the report is true. So the Recreation Department recruits a sample of 185 adult residents who volunteer to take the physical fitness test. The test is passed by 77 of the 185 volunteers. Complete a significance test and make a recommendation to the City Council. All right, so if we're going to do that, we have to start with our state section. So the first thing we have to do is describe in context what P is and then find our P hat. So P would be the true proportion of adult residents in a certain city who can pass a physical fitness test. And then P hat, so that sample they had was 77 out of 185. And that gives us 0.4162. Then we need to write our two hypotheses. So for our hypotheses, we need to have our null hypothesis and then what we're trying to prove. So in this case, what we're trying to prove is that less than 35% of the city can pass the physical fitness test. So that means we need to start with our null hypothesis being P equals 35%. Now, we always want to not write these as percent. We want to write them in decimal form. So we want to include them so they look like that. And you want to make sure that when you're writing these, that the numbers are always the same in your two hypotheses. They should always match up. They don't give us a significance level, so we're just going to assume that our alpha is 0.05 and move on with the rest of the problem. And the last thing we need to do is we need to check and make sure we have evidence for our alternate hypothesis. All right, so our alternate hypothesis is P is less than 0.35. So we want to make sure our sample, our P hat, is less than 0.35. It's not. Our P hat is 0.462. So our sample does not match what we were attempting to prove. So we can't run this test. We didn't find evidence for HA. So we would stop. So where we could go with this is I could ask you, okay, what would happen? What was wrong? And if you go back up in that paragraph and we kind of put on our experimental design hat for a second, they said they recruited a sample of 185 adult residents who volunteer. So what we're getting at there is odds are you are probably more likely to volunteer to take a physical fitness test if you enjoy doing physical fitness, physical activities of some way. You're not going to volunteer to take it if you aren't interested in that in any way, shape, or form. So they probably had a biased sample. They had more than what they were looking for. So what they could do to correct this would be to design a study where it was a random sample instead of asking for volunteers, and that probably would give them a better idea. It's still not going to be perfect because you're going to have to basically identify these random people and cold call them till we can get people that actually agree. It's still going to be pretty challenging, but the issue here definitely is they just had volunteers. But in this case, we can't do anything else with this problem. We don't have evidence for our alternate hypothesis, so it is pointless to go through the procedure to prove whether or not our null hypothesis is true or false, because right now we don't have any evidence against it. All right, so then let's take a look at example 2. So for this one, according to the Centers for Disease Control website, 27.5% of all high school students in 2019 used e-cigarettes. Sean wonders if this national result holds true in his large suburban high school. He collects data from an SRS of 150 students at his school. 29 of them have smoked an e-cigarette. Is there convincing evidence at the alpha equals 0.05 significance level that the proportion of all students at Sean's school who have smoked an e-cigarette differs from the national result? All right, so part A, we're doing a significance test. That's what it's asking us to walk through. So again, with our state, we have to identify our population proportion and our sample proportion. So P is the true proportion of all students at Sean's school who have smoked an e-cigarette. And then P hat is 29 out of the 150 classmates that he talked to. And so that P hat ends up being 0.1933. Now, this is where we run into some things that are different with our hypotheses. So the question was asking, is the proportion of all students at Sean School have smoked an e-cigarette, does it differ from the national result? Everything we've seen so far would be less than the national result or higher than the national result. This is just saying differs, so it's just different. That means it could be bigger or it could be smaller. And so this is where we run into things called a two-tailed hypothesis. And basically what it means is we are checking the probability that it's below and it's the probability that it's above. We're taking both. So our null hypothesis is what the CDC's website said, 27.5% or 0.275. Then our alternate hypothesis is just saying, okay, it just can't equal 0.275. So that's why it's not equal to. They do give us a significance level, so we can go ahead and say alpha equals 0.05. And then we want to check for our evidence, just like we found out in the last problem. If we don't check, there's a chance we could run a test for no good reason. So we're checking our p-hat against our null hypothesis. And our p-hat is 0.1933. Our null hypothesis is 0.275, and yes, that works. 0.1933 does not equal 0.275, so we're good. So then from here, we want to proceed into our plan step. So we need to name our test, and we need to check our conditions. So this is a one-sample z-test for p, following the same pattern we've been using. Then for conditions, we want to check random, we want to check independence, and we want to check normal. So for random, they told us, that Sean took a SRS of 150 students. So we're good there. For independence, the 10% condition, we can assume that there are at least 1,500 students in Sean's school. They're saying it's a large suburban high school. Odds are 1,500 seems absolutely reasonable for at least. Then for large counts, the one thing we want to be careful is make sure, remember, we are going to be, when we're testing assuming the null hypothesis is true. So we're checking to make sure our null hypothesis sampling's distribution is approximately normal, not our sample. So we have to be careful with that. So looking at this, I'm checking large counts with P0 or P null, and I end up getting 41 and 108. So yeah, we're good. Both of those are bigger than 10. So we've checked all three conditions. All three conditions have been met. We're good. We can actually proceed with the calculations. So what we need to do first is find our z-score, and the formula for z-score, p-hat minus p-null over our standard error. I like to calculate the standard error separately. So standard error is the square root of p-null times 1 minus p-null over 0. So when I calculate the standard error, I get 0.0365. And then when I plug into my formula over here on the left, I'm going to get 0.1933 minus 0.275 all over 0.0365. So if I was doing this by hand, I would then go ahead and finish, get my z-score, go to table A, and find that probability. Now, what's different about these is when we are dealing with our two-tailed hypotheses, we actually end up having to do something slightly different with table A. So over here on the left, this piece is based off of our p-hat. But our alternate hypothesis was saying just that p couldn't equal our p-null, our 0.275. It just had to be different. So it could be far away down to the left, meaning it's much smaller, but it could also be that same distance above to the right. So we actually have to have both pieces, because it's not just less than or just greater than, it's both when we have not equal to. So the way I figured out what that number was, I just figured out what my distance was here. I just subtracted. And then I added that to figure out what this new number would have to be. So if I'm doing this by hand, I'm going to find my z-score, I'm going to go to table A, I'm going to get that probability, and then I'm going to double it, because it should be the same on either side, and I have to include both. If you want to go through and by hand calculate a second z-score, and then go to table A and do that process again, you can, but that takes way too long. don't do that. All right, just figure out what your first probability is and double it. Much easier. That being said, for a lot of folks, when we get to significance tests and we run into the issue of having these two-tailed hypotheses, they really like using the calculator because the calculator will do all of that work for you. All you have to do is get to this point. Once you get here, you have all the information you need to get the answer out of your calculator, and more importantly, you have all the stuff on your paper that you need for College Board to give you full credit. So you got notes yesterday that had the calculator steps on them, so pick either your the Inspire notes or the 84 notes, whichever one you use. Both of them require the same 4 pieces of information. They need the null hypothesis. They need the number of successes you actually got in your sample. They need your sample size. And then the last thing you have to do is you have to choose. It's a drop-down menu on the Inspire. On the TI 83, 84, you just have to toggle left and right with your arrow keys. But on either one, you have to select the correct alternate hypothesis. So you have to go through and say, okay, for this problem, I'm doing not equals to. So you want to make sure you select that one versus the less than or versus the greater than. So in this case, we're picking not equal to. And when you do that, then the calculator knows what to do. It knows to just multiply by 2. So when you do that in your calculator, over here, what's in red, this is what the computer output would be, or your calculator output. That's what you'll get on your screen. It's a little prettier if you have the Inspire, depending on your operating system, but for the 83, 84, that's what you get out of it. So from there, you now know your z-score. You absolutely could have calculated that by hand. That's fine. But you can also let the calculator do it for you. All right, and then this value right here, that's your p-value. All right, so sliding it over here, I need to go ahead and make that obvious. Both of these two things you saw on the front of these notes, these are the 2 things that they're looking for. They want to see all the supporting work, but these are the numbers that have to be correct. So take it easy on your graders, make it easy for them to find it, make sure you're labeling them. All right, now that we have our p-value, then we can move on to what section 3 is, and that's where we make our judgment call. So we are comparing our p-value against our alpha. We were using an alpha of 0.05, and so we have to check our p-value against that. Our p-value is smaller than our alpha. So back on Monday, we talked about how to decide to make our conclusions, whether we're rejecting or failing to reject. If our alpha is small, that means it's highly unlikely that we got our sample just by random chance. That means that our null hypothesis is probably wrong. We have enough evidence. It is extremely unlikely we just get this randomly. That means our null hypothesis is wrong. In this case, we're looking at a probability of getting our sample is 2.5%. That's real low to get just by random chance, and that's enough. It's below the cutoff. So the 2 sentences we need to include have to cover those 3 things on the front of the notes that we were talking about. So we need to compare our p-value to our alpha. We need to have draw our correct conclusion, and then we need to make sure our conclusion is in context. All right, so the first sentence takes care of the first 2. So first, drawing the correct conclusion and comparing my p-value to the alpha. So we're rejecting the null hypothesis. That's the conclusion. All right, we're rejecting the null hypothesis because our p-value of 0.025 is less than the alpha of 0.05. So you need to say that. You need to say that your p-value is smaller than your alpha. You need to include the numbers to back it up. The second part here is the context. So we do have convincing evidence that the true proportion of all students at Sean School who have smoked e-cigarettes is significantly different than 0.0251. If it was the other 2, if we were doing a less than or a greater than hypothesis, it might be significantly lower, it might be significantly higher. In this case, when it's not equal to, it's significantly different. All right, then the very last thing is part B, and this is on the back of that second page or at the top of the fourth page of notes. It says, based on your conclusion from part A, which of the two errors, type 1 or type 2, could have been made? Interpret the consequence of the error in context. Okay, so that wording is literally straight off of last year's AP exam. They had a question just like this as part B. So what we're looking at here, we rejected our null hypothesis. So when we talked about our type 1 and type 2 errors, type 1 was we reject the null hypothesis, but it was actually correct. Type 2 is we failed to reject the null hypothesis, but it was actually wrong. We should have. So in this case, because we rejected the null hypothesis, the only error we could have made is a type 1 error. Type 2 means we failed to reject. We didn't. We rejected it. So you can only pick one if they're asking you which one you could have made. So if you rejected your null hypothesis, you could have made a type 1. If you failed to reject your null hypothesis, you could have made a type 2. All right, so we reject our null hypothesis, so we only could have made a type 1 error. So the consequences for this, there's not, in this particular problem, there's not necessarily significant consequences. So we're going to give them the context. So this would mean that Sean thought his school's true proportion of students who smoked e-cigarettes was different than the national result, but in reality, they were the same. So maybe they were applying for funding for a grant, and they thought they were different than that cutoff, and that was part of the reason they were able to get money. But in reality, that wasn't true, and then maybe they had to give the grant back. Different things like that. There could be some level of consequences. For now, for a question like this, if they're going to ask you what the consequences are, they will have laid it out in the problem for you. It's not something you're going to have to guess at. But they do want the context. They do want to know, what does this mean in the situation? Okay, so pretty much that's it from what we covered today, and plus a little extra. On Monday, we are going to start doing significance tests with 2 proportions. And what I'm going to do is, I've kind of made an executive decision. I know for some of the classes I was asking you guys what you thought. I am going to go ahead and move the TWIS until Tuesday, and I'm going to make it on 9-1 and 9-2. That way you get some feedback on a full procedure before the test. So Monday and Tuesday are going to be doing these tests with 2 proportions. It's just like it was with confidence intervals. The whole procedure is almost identical. It's just you have 2 now instead of 1. So we're going to look at that on Monday, and then practice on Tuesday, TWIS on Tuesday from this week's material. Thursday will be a review day. Friday is the test. So I'm going to grade those TWISs quick on Wednesday, so you can get them back at the beginning of class on Thursday and at least get some feedback before we have to look at the test. I just didn't want you to go into the test without at least having assessed on one of these significance tests. You need a little feedback on it first. So that's what we're going to do. Next week should be otherwise relatively chill, not a whole lot of new material, just looking at those 2 proportion significance tests. And then we will start Unit 6 the following Monday. All right, everybody, I hope you're hanging in there and not going too crazy. Please take care of yourselves. If you need anything, please reach out. I'll be around this weekend. Otherwise, I will talk to you all later.